Okay, more solving trig. Remember, solving, not proving, so there's things I'm doing on both sides of the equation because I am solving it. When I look at this problem, it's already in sines and cosines, and I have a mixture of them, and this isn't like factorable or anything else, so I am going to move the cosine x to the other side. So you have sine x plus 1 equals cosine x. Then I'm going to square both sides because I can't replace sine x with anything from our formulas. I can't replace cosine x with anything, but there are some squared ones on that formula sheet, right? So remember, when you square sine x plus 1, that is not sine squared plus cosine, or sine squared plus 1, right? You have to do an area diagram or FOIL. So if you took the time to do that, you can always pause your video and take the time to do that. You get this. Cosine just becomes cosine squared x. Now, I can't solve an equation that has sines on one side and cosines on the other, but cosine squared is on our identities. So I'm going to leave this side. Cosine squared x is 1 minus sine squared x. Now all my trig matches. Now I need to move it all to the same side, move it to the left, minus the 1 and add the sine squared. I was minusing 1, so just equals 0. Factor and zero product property. This happens to just be GCF factoring. So factor out the GCF. 2 sine x is in both of those. Divide by 2 sine x and you just get sine x. Divide by 2 sine x and you still get 1. It does not disappear. Zero product property. Divide by 2 and you just get sine x equals 0, minus the 1, and sine x equals negative 1. So on a unit circle, let's do sine equals 0, the left first. Sine is the y value, right? So a y value of 0 here and here. The sine x equals negative 1, again, y value down here. Here's the thing though, as soon as I squared both sides, I potentially created an extraneous solution. These were talked about in integrated 3. Anytime you square a variable, you could have created an extraneous solution. So if and only if you squared something, you need to check those possible solutions before you try wrapping them and all that. So I'm going to check. Here's my original equation, right? So that's what I'm going to check it in. Let's label this. This is 0, this is pi, and this is 3 pi over 2, right? So let's check 0. Sine of 0 plus 1 minus cosine of 0 should equal 0. Sine of 0, so I would draw a little tiny unit circle for all of these. You guys should pause it and see if you can find all these answers. Sine is the y value at 0, radians is 0, plus 1 minus cosine is the x value at 0 radians, and that does equal 0, so that is a solution. We'll check pi next, just going around. Sine of pi plus 1 minus cosine of pi should equal 0. At pi, sine is the y value. At pi, cosine is the x value. That gives me 2, which clearly does not equal 0, so pi is not a solution, so I'm going to get rid of that one. Now we need to check our possible third solution, 3 pi over 2. Sine of 3 pi over 2 plus 1 minus cosine of 3 pi over 2 is supposed to equal 0 for this equation. I'm just plugging it into the original equation. At 3 pi over 2, sine is negative 1, plus 1 minus, at 3 pi over 2, cosine is 0, and that does equal 0, so that does work. So there's 2 solutions. Clearly the gap between them from here to here and from there to there is not the same, so you cannot wrap them. You will have to write each one with all of the coterminal angles, right? Plus or minus 2 pi n. And then the second one, 3 pi over 2 plus or minus 2 pi n. Now's a good time to mention that, especially in the multiple choice, it might say within the domain 0 to 2 pi. That would be just the answer 0, 3 pi over 2, right? If it tells you within a given domain, give me the solutions, they're not going to do the plus minus 2 pi n. Also, remember I said they might use k instead. But it'll be really obvious, right? If all the choices only have 2 answers and they're not doing the infinite coterminal angles, then you know they just wanted the 2 answers. So, important part on this page, if you square both sides, you could have created an extraneous solution. If you forget to check, you're just going to get it wrong, right? You have to check all 3 answers, make sure however many of them actually are the solution. Number 2. I just have cosine x plus 3, so I'll move the 3 to the other side. Cosine x equals negative 3, little tiny unit circle. Where on the unit circle does cosine x equals negative 3? Well, cosine is the x value, right? Can it go out 3 units and be on the unit circle? No, the unit circle only goes out 1 unit. This does not exist. Here's the thing though. If it was, let me change colors, secant x plus 3 equals 0, and then you'd get secant x equals negative 3. Secant is really 1 over cosine, right? So cosine x would equal negative 1/3. That does exist. So don't just think if the number is bigger than 1, it never exists, right? Because if something's bigger than 1, and then I do the reciprocal, I can get 1/3, like in this example. I just made this up, so this isn't going to work out nicely, right? That's not anything on the unit circle. But I should have used 2, and then it would have worked. But just keep an eye out. Don't just instantly say it does not exist. Okay, number 4. Everything is signs, so that's good. I don't need to replace anything. I should move everything to one side, so I'm going to minus the 2x to the other side. And I'm going to squeeze it in the middle, kind of. I don't like, or I guess I do like having that constant at the end. So we'll keep 4 sine squared x plus 2 root 3 sine x. And I'm going to squeeze it in, minus 2 sine x minus root 3 equals 0. First thing you should notice is that there are 4 terms. What do we do when there's 4 terms? We do grouping. So with a pencil, put the first 2 in parentheses. What do they both have in common? Well, they both have a 2 that I can factor out, and they both have a sine x that I can factor out. So divide out 2 sine x. I'll have 2 sine x left for the first one. Plus, I'm dividing out the 2 and the sine x. I'll just have root 3 left for the second one. Remember, when you are doing grouping, this one has to match. So I like to fill it in ahead of time. What do you need to factor out? Remember, the negative goes with it, of that in order to get 2 sine x plus 3. Well, you need to factor out negative 1. Double check me and make sure you understand what I did there. Still equals 0. Then remember, in grouping, you take the matching group. That's one of the factors. And then you take your leftovers. So that was one of the factors. I'm going to take my leftovers and put them in the other factor. Now it's just like the ones we've done previously. Go ahead and set up zero product property and see how far you can get on this one. Pause your video and try it on your own. I'm going to skip some steps here. You should be trying this on your own. Minus the root 3 and then divide by 2. Add the 1 and then divide by 2. On a unit circle. Sine is the y value. So I've got a sine value of negative root 3 over 2. That would be the long y values on either side. And then I have a sine value of positive 1/2. That's the short ones on either side. Check and see if you can wrap this in any way. I can clearly see none of these gaps are the same. That gap does not match. Well, I don't know. It might match that one, but it clearly does not match that gap. So I don't see any way to make any of these gaps match. So all 4 answers with every coterminal angle. Just going counterclockwise around the circle, close to the x-axis, Remember, you need to understand your unit circle to pass this skill. Close to the x-axis in quadrant 1 is pi over 6, plus or minus a whole circle. Quadrant 2, close to the x-axis, 5 pi over 6, plus or minus a whole circle. In quadrant 3, it's the one close to the y-axis, 4 pi over 3, whole circle. And in quadrant 4, it's close to the y-axis, that's the 5 pi over 3 spot. So these are the 4 solutions that really represent an infinite number of solutions that make our equation true. Okay, number 4. So 2 different trig functions, not replaceable, so I'm going to move them to opposite sides. So add the cosine x to the other side. Sine x equals cosine x. Now, theoretically, you could square both sides of this, but remember, when you square something, you create an extraneous solution. But I'm considering squaring it because sine squared is replaceable with 1 minus cosine squared, and then I could make all the trig match. But this is a good time to show you one of the things you are allowed to do. Remember, we talked about you're not allowed to cross out a whole trig function because you would be deleting one of the possible answers, but you are allowed to manipulate. So if I divide by cosine x, on this side I get 1. On this side, I'm not deleting any x's. Sine over cosine is tangent. So this is a good one to practice your tangent skills. Where on the unit circle is tangent positive 1? Remember, tangent is the slope of the line. The ones that go through the middle, positive 1, and then this quadrant is the positive 1 too. It's the straight line that crosses all the way through. This is pi over 4, and this is 5 pi over 4. Tangent wraps nicely, right? There's a difference of pi from here to here, and a distance of pi from there to there. So x equals pi over 4 plus or minus pi n wraps up the entire solution. So if you're going to divide by a trig function, notice I didn't cross anything out on that side. I just transformed this to its actual equivalent solution. Just as a heads up, you also could have just thought this one through. We were at sine x equals cosine x. This is just saying the y value equals the x value. Where on the unit circle are your coordinates the same, right? This is 2 root 2 comma 2 root 2. That's a place the coordinates are the same. And this is negative root 2 over, comma, negative root 2. That's another place the coordinates are the same. So sometimes, rarely, you can just kind of see the answer. Okay, look closely at this one and notice the 4x. Also, that could be theta or some other variable, right? We talked about that the first day. So when you're dealing with multiple x's or thetas, we do what's called a U-substitution. We're going to make it easier to start, and then we'll deal with that at the end. So pretend it doesn't say 4x, right? We'll pretend it says u. U is just the variable mathematicians use a lot when they're doing substitutions. So I'll make it cosine u equals negative root 2 over 2. Well, that I can solve. On a unit circle, where does the x value equal negative root 2 over 2? See if you can pause it and go from here, just pretending that the question was cosine u. Here and here. 3 pi over 4 and 5 pi over 4. And then you see if you can wrap it. These ones don't wrap, right? Clearly, this gap is bigger than this gap. So each one gets written out. So if the problem was u, I would say u equals 3 pi over 4 plus or minus 2 pi n. And I would say u equals 5 pi over 4 plus or minus 2 pi n. But the question wasn't u, right? It was 4x. So wherever I see a u, I'm going to replace it with 4x. Well, now, if I'm just solving for x, all I have to do is divide that by 4, which means I'm going to divide everything by 4. Remember, if it's already divided by a number, you just multiply those together. So this becomes 3 pi over 16, and then I need to put that over 4 as well, which reduces to pi over 2 n. See if you can do it on the other side. That's one of our solutions. Divide the other one by 4 carefully. 5 pi over 16 plus or minus, I'll leave it just so you guys understand how I got it. That reduces to pi over 2, but just so you understand. These would be our solutions for cosine 4x equals negative root 2 over 2. Okay, so if we can do U substitution in a short little tiny problem like that one, we can do U substitution in bigger problems. So this time we'll let u equal 3x. I want you to practice this one. Pause the video. 2 cosine u minus 1 equals 0. See if you can find all the solutions just for that. Don't worry that it's a u. We'll deal with that at the very, very end. If you add the 1 and divide by 2, you get cosine u equals 1/2. X of 1/2, it's really short x's here and here. Can't be wrapped, so one of them would be u equals, that's pi over 3 plus or minus a whole circle. The other would be u equals, that's 5 pi over 3 plus or minus a whole circle. But it wasn't u, and if you stop here, you lose kind of a lot of points. It was 3x. 3x equals this entire thing. See if you can divide and finish solving it. 3x equals this entire thing. Divide everybody by 3. If it was already over a number, I multiply them, so that's pi over 9. And this one actually doesn't reduce. 2 pi over 3n. Divide by 3. 5 pi over 9 plus or minus 2 pi over 3n. So it just adds one step at the end, but you can't forget that last step. You'd be surprised how many times students just panic when they see the 3x. So I need you to make a note of this, highlight this, do something so that you remember what to do in this situation. Okay, here's another example. X is over 2. People panic because there's something crazy next to that. We'll just make u equal x over 2 and we'll deal with it at the end. So again, pause the video and try to solve this on your own. 3 tan u plus 3 equals 0. Pause the video and go as far as you can on your own. Minus a 3, divide by 3. Tangent equals negative 1. Tangent is the slope. Tangent's negative in these corners, and it needs to be in the middle to be negative 1, right? So this spot is 3 pi over 4, and tangent always wraps by pi because it's right in the middle of the circle, right? That line, halfway to there, pi each way. So u would equal 3 pi over 4 plus or minus pi n. You wrap it before you substitute back in. But now we remember the teacher did not ask for u, they asked for x. So x over 2 equals this big solution. So now instead of dividing, to get rid of x over 2, I'm going to multiply everything by 2. That'll give me just x. Multiply happens on top. So you could write 6 pi over 4 plus or minus 2 pi n, distribute the 2, but if it's multiple choice, it's probably going to be reduced, right? 6 over 4 reduces to 3 over 2, and this is what your solution is for x. Okay, last one for today. It's a pretty straightforward one, except it's got cosecants in it, but make it equal 0 first, so add the 2. It's a trinomial. You need to, again, be able to recognize that that's basically the same thing as x squared minus 3x plus 2 equals 0. If you can factor this, then you can factor this. So feel free to do the orange one first, make an area diagram if that's how you do it, and then see if you can translate that to the blue one. So this would be cosecant x minus 1 times cosecant x minus 2. You could always multiply it out on an area diagram to double check. Then, zero product property. Solve for cosecant. Solve for cosecant. I don't like reciprocal trig, so I'm going to change each one to its reciprocal. See if you can change these to their reciprocal trigs correctly. What would that equation say? Cosecant is sine. When I flip 1 over, though, I still have 1. Cosecant is sine, and when I flip 2 over, I have 1/2. So make sure right here, when you saw it was bigger than 1, that does not mean it doesn't exist because this is cosecant. When I flip it over, it does exist. So both of these land on the unit circle. Plot them and see if you can wrap them and find all of your solutions. Pause it. At this point, you should be trying these on your own. See if you can find the solutions. Sine x equals 1 at the top. Sine x equals positive 1/2, really close to the x-axis. I can't wrap these, the gaps aren't the same. So pi over 6, whole circle, pi over 2, all the way around multiple times, 5 pi over 6, forwards and backwards all the way around multiple times. These are our solutions. So I hope you're getting better at this. Make sure you're doing all the practice that's assigned, and we'll continue to practice more in class, and I hope you guys are doing good.